keep this simple with the simplest example. Imagine two of these spherical waves approach each other. They are moving in directly opposite directions. They have the same wavelength. Their polarizations are attractive. When they pass through each other, their fields attract in a perfect fashion. They collide. They make a neutral particle. In this case, it is a neutrino. So we have made a basic particle. Next, imagine a third wave is superimposed on top of this neutral particle. Again, the particle is made using just two waves. The third wave is identical to one of the first two waves. The third wave would sweep back and forth over the neutral particle. Here's an animation of that. I believe something like this is what is happening on the surface of electrons. Again, there are two main types of waves, moving waves and standing waves. Just keep this detail in mind, and this might seem a little odd at first. Standing waves can move. How should we visualize elementary particles? At this point in history, most people still think of elementary particles as small, solid objects, kind of like the old billiard ball idea. In my opinion, it is far better to think of them as hollow spherical waves, hollow standing spherical waves. In essence, neutrinos, electrons, protons are all examples of standing spherical waves. Further, completely forget the idea that elementary particles are only small. Do not even think of elementary particles as being microscopic. While everyday experience gives us the impression that elementary particles are small, there is nothing in the physics that prevents elementary particles from being large. Very large. Gigantic. Think about it. In Einstein's equation, E equals mc squared, what part of that equation deals with size? There is nothing in this critical equation that limits the size of the particle. Get over the idea that elementary particles are very small. In my opinion, they can be much larger than is imagined. This is just one of the reasons astronomy is going to change. Big time. So to recap, in essence, when the photons collide under the correct conditions, they simply combine and make elementary particles of matter. What I'm describing here is something that is equal and opposite. Two or more waves can combine, two or more waves can uncombine. When they combine, it is called fusion. When they split, it is called fission. In my opinion, fission and fusion are much broader concepts than physicists have been describing in the past. Earlier in this film, I said every physicist needs to be able to clearly understand and visualize exactly how this transformation takes place. How does matter transform into energy, and how does energy transform into matter? Now we are looking directly at this transformation. Think of an elementary particle as being like a soap bubble. Two moving spherical waves can combine to create a standing wave, creating something like a bubble. Or the particle can decay. It disintegrates. In essence, the bubble pops. When the bubble pops, it leaves photons that are moving apart. So two possibilities. Energy in the form of photons can combine to create matter, or when the bubble pops, energy in the form of photons flies out. Equal and opposite. Let me emphasize, this is the essence of E equals mc squared. Again, mass can be converted into energy, and energy can be converted into mass. The pointing vector shows us why. Regrettably, I must move on. So let me summarize this critical concept. The reason photons come out of elementary particles of matter when they decay or disintegrate is because that is what elementary particles are made of. In my opinion, all photons, all elementary particles, all atomic nuclei, they are all made up of these spherical waves. And again, let me emphasize, these spherical waves have 3 fields. Much of what you already know about waves applies to spherical waves. Concepts like wavelength, frequency, nodes, antinodes, they're all the same. However, there are some differences. Let me point out some of the details. In spherical waves, one field sweeps from pole to pole. I call it the primary field. Sometimes the primary field is electric. Sometimes it is magnetic. This depiction of a primary field is generic. I represent it with the color yellow. I represent the electric field with magenta and the magnetic field with blue. Therefore, if an electric field is sweeping from pole to pole, it would look like this. Or if a magnetic field is sweeping from pole to pole, it would look like this. Mathematicians need to keep in mind there's something special happening at each pole and at the equator. Next, I need to describe the secondary field. There are 2 possible scenarios. In the first scenario, imagine the electric field is sweeping over the sphere. In this case, it is the primary field and it is sweeping from one pole to the other pole. When this happens, the magnetic field curls like this. Of course, this is the critical experiment that I showed earlier. Over the first hemisphere, the magnetic field curls to the left. Over the second hemisphere, the magnetic field curls to the right. Next, let's examine the second scenario. Imagine that a magnetic field sweeps over the sphere from one pole to another. When this happens, the electric field curls like this. Over the first hemisphere, the electric field curls to the right. Over the second hemisphere, the electric field curls to the left. Notice how this is opposite to when the magnetic field is secondary. I call these induced fields the secondary fields. Therefore, using my terminology, the primary field sweeps in one direction from pole to pole. The secondary fields counter-rotate in 2 directions around each hemisphere. This is easy to remember. The primary field travels in one direction. The secondary field travels in 2 directions. Keep in mind, just like the primary field is one field, the secondary field is also just one field, not 2. Do not think of the secondary field as 2 fields, just because it is curling in opposite directions in each hemisphere. Mathematicians need to make a mental note. I'll refer to this topic later when I talk about the hairy ball theorem. Also, mathematicians need to keep in mind there's something special happening at each pole and at the equator. Okay, now this is not just a theory. Nature really does work this way. Here's one way you can make a magnetic field sweep from pole to pole on a conducting sphere. It is a type of coil I call a hemispheric coil. I designed them for use in my fusion power plants. I have stabilized the wire on this ball by using clear tape, so it is easy for you to see. Take a close look. These are very simple to make. Try taking some ping pong balls like this and wrapping some wire around half of a ping pong ball. Use some clear tape and just tape the wire on there and that will stabilize it. I recommend that you try making a couple of hemispheric coils for yourself. Then just take a few minutes and ponder how their field's different from a regular coil. In a fusion power plant, a coil like this would need much stronger support because the coil would be experiencing extremely powerful magnetic fields. Therefore, the coil would need to be embedded in a much stronger material. Plastic tape wouldn't work. For example, a carbon-carbon matrix would be good. That is the kind of material that we now use to make many of our fighter planes. Here's a larger hemispheric coil wrapped around a copper sphere. Really, this is very simple to understand and test. If you have current flow around through this wire. The current spins around the surface of the sphere and induces a magnetic field that sweeps from pole to pole. So again, there's two wires here, and you just apply voltage across the wire. The current flows through the hemispheric coil over the sphere, and as the field is induced by the coil, it will induce fields in the surface of the sphere. This is a 4-inch copper ball. This is used for a prototype for my fusion power plant design. Anyhow, they are simple and trivial to test. If you would like to analyze the fields for a hemispheric coil, then this is how I describe them. While I'm describing a grand unification theory, obviously it goes beyond being just a theory if it is so extremely simple to test. By the way, the United States Patent Office did not allow my patent application for this very important type of coil. Apparently, the patent examiner thought hemispheric coils and hemispheric transformers were just way too obvious. Oh well, since apparently this cannot be patented, if this is the kind of thing that interests you, then you might consider going into the business of making transformers that use this spherical geometry. So there's a business opportunity, something you can make money on.